In blue, we have x to the 7th power divided by x to the 7th power. Since we have division, that tells me I should use the quotient rule. And the quotient rule tells me let's subtract the exponents, which gets me x to the 0 power. Now you should know that a number divided by the same number, like 5 divided by 5, gets me 1. That's exactly what x to the 7th divided by x to the 7th is. X just represents an unknown number. So x to the 7th divided by x to the 7th is equal to 1. So the 0 power just tells us the answer is 1. Now, here we get a little bit more complicated. I have y squared times x to the 4th power times z to the 10th power, all divided by x to the 4th power times y squared times w. Now, it has division, so I can use the quotient rule, but I also know, actually I'm going to change this, sorry, w to the 0 power. So I know, using the quotient rule, that y squared divided by y squared is y to the 0, which is just 1, so it cancels out. Z to the 4th over z to the 4th is just z to the 0 power, which is just 1. W to the 1st power is just 1, so we get z to the 10th power. So it may have looked crazy at the beginning, but really wasn't that challenging. Let's just do one more. Let's say I have w to the 0 power, z to the 0 power, y to the 7th power. Well, w to the 0 power is 1. Z to the 0 power is 1. So our final answer is y to the 7th power. So in blue, we have x divided by x to the 4th power. So if we expand this, we get x over x times x times x times x. And when we simplify it, we really get 1 over x to the 3rd power, because there's more x's in the denominator than the numerator. Using the quotient rule, we would do x to the 1st power minus 4, which gets us x to negative 3rd. So in other words, x to negative 3rd is the same thing as x to the 3rd power. So let's practice with y to negative 11th power. Sometimes directions say please write with a positive exponent. So to make y to the negative 11th power positive, that is the same thing as 1 over y to the 11th power. You just flip it. You write the reciprocal. Let's practice with 1 over m to the negative 3rd. Let's make it a positive exponent. So we just gotta flip it. And so it becomes m to the 3rd power over 1. And you know we don't need the denominator of 1. So it's just m to the 3rd power. So let's get a little bit more complicated. And let's make sure that the exponents stay positive. So we have m to the 7th times y to the 2nd all over y to the 6th power times m to the 3rd. Now I can use the quotient rule, and that would tell me this is m to the 4th power and y to the negative 4th. So then I'd flip it, so it's m to the 4th power over y to the 4th. However, what I tend to do is I see that there's more m's in the numerator, so I know it's m to the 4th in the numerator. I see that the y's have more in the denominator, so I know the y needs to be in the denominator. So I can skip all the way to this step. And if you can do that yourself, you are welcome to as well. Now in purple, we have x to the negative 3rd times n to the negative 2nd all over z to negative 4th. Oh, making those positive, we would just flip it. So the x to the 3rd goes to the denominator, n to the squared goes to the denominator, and the z, which I don't know how to write, goes to the 4th power.